Everyone. Am I audible? This is day 2. This is day 5, session 2, the last session. After this session, there will be feedback, exam, and valedictory program will be starting at in session 3 at 2:30 p.m. Links were updated to you on WhatsApp group as well as in chat box on time-to-time basis. So here we are going to start our session, and the same speaker of the earlier session will continue for this session also. They are supposed from participants to do some activities parallelly with the help of some simulators. Those who were comfortable and having little bit exposure earlier with the IoT simulators can do it. We expect that you will utilize this opportunity to have a small hands-on session. But there are some limitations as of it is in online mode. But those who can catch it with the flow are really welcome for the same. So I welcome once again to the speaker of the day and all participants. Good afternoon, everyone. Renuka Suryavanshi ma'am is supposed to start our day 5th second session. Over to you, ma'am.
Yes, thank you so much, sir. Yes, as in the morning slot, I've started with the different platforms like Arduino boards and all. So right now, I just want to continue with the second board, which supposed to be the Raspberry Pi board. Okay, so first I'll start with the Raspberry Pi board, and then we'll start with the second actual whatever we have decided as per the second slot. We are going to be discuss about the different application protocol, the hands-on and all. So initially I'll start with the first Arduino board and just a second, let me share my screen. So my screen is visible to you all? Can you see my screen?
Yes, ma'am, it's visible.
Yeah, thank you so much. So here, I want to start with first Raspberry Pi. In the Raspberry Pi, I would like to discuss the which are the different versions of the Raspberry Pi and which operating system which we require if we are looking for the Raspberry Pi. What are the different applications where we can whenever we are designing a particular IoT application, that time the first thing which comes in the mind comes in our mind. Yes, what will be the platform? So that's why I will start with the first Raspberry Pi. Just a second. Yeah. So what is Raspberry Pi? Raspberry Pi is a series of small single board computers developed in a United Kingdom by Raspberry Pi Foundation to promote the teaching of basic computer science in schools and developing the countries. The original model became far more popular than the anticipated one, selling outside of its target market for use such as robotics and all. So robotics kind of means in previous years. So basically it was famous for the robotics kind of an application. Over 5 million of Raspberry Pi have been sold before the 2015 and making it for the best-selling British computer. So by November 2016, they said it sold 11 million units. So you can understand the popularity of the Raspberry Pi. If you can see the graph from the 2012 till 15, you can see how drastically the Raspberry Pi selling graphs they have changed. Because the thing is, what actually happened that time, that many educational institute and like those who are actually interested in the embedding system and all, they have started using the Raspberry Pi for the education purpose as well. And so from that time only, Raspberry Pi launched many different versions. So you can see here, the one of the first one is the Raspberry Pi 3 model B, which you can see on my screen. So Raspberry Pi 3 Model B is the one of the first launch Raspberry Pi version. Okay, so it's a first generation Raspberry Pi Model B, and it was released in February 2012. It was followed by the simpler and inexpensive Model A. Whereas after 2012 and 2014, the foundation released a board with the improved design that's supposed to be Raspberry Pi Model B Plus. Okay, and if you're going to be compare this model, I'll explain you each and everything about this Model B and B Plus. These boards are approximately credit card size and represent a standard mainline form factor. The reason behind this Raspberry Pi or such a kind of small device is supposed to be the portability, because we know that if we are looking for any processing and all, we require the huge big kind of a devices. Either we need to use a laptop or a desktop and all. Whereas if you have such a small kind of a system which will give you a similar kind of a feature, why don't you? So that's why for such a kind of embedded kind of a system, this Raspberry Pi first of all comes in the picture. After a few years, they have also improved. They have also come with a new feature. So improved A plus and B plus model were released a year later. A computer model was released in April 2014 for embedded applications called as a Raspberry Pi Zero. Is one of the famous version of the Raspberry Pi with a very smaller size, like your credit card size, and it's reduced input output pins as well as the general purpose input output pins, and was released in 2015. Okay, and after that, if you can see the timeline, the Raspberry Pi 2, which added a more RAM, was released in the February 2015. Raspberry Pi Model B released in 2016, which is bundled with the onboard Wi-Fi, Bluetooth, and the USB boot capabilities. This is the one of the best feature of the Raspberry Pi, because if you can see, these features are not available with your Wi-Fi and Bluetooth is not available with the Arduino board, but yes, USB is available. USB port is available. So this is the Raspberry Pi Model B, and they have come with the Wi-Fi, Bluetooth, and the USB boot capabilities. After 2016 or 17, the newest mainline Raspberry Pi they have launched. Again, if you can see the on 20th February 2017, Raspberry Pi Zero W was launched, which is identical to the Raspberry Pi Zero, but has a Wi-Fi and Bluetooth functionality of the Raspberry Pi. And you can see the price of this. So the in the market, these Raspberry Pis they were available with a very cheap price. Can you, sir? Can you see my screen? Is this visible properly? And can you hear me?
Yes, ma'am.
Yes, ma'am, audible.
Yeah, thank you so much. So so we are talking about the different versions of the Raspberry Pi and all. So you can see here till date we have received many different versions of the Raspberry Pi, or the flavors of the Raspberry Pi, which having lots of different features and all. Wait a second, just give me a second. Okay, so here now we are going to be talk about the features. All model features are Broadcom system on chip. Listen, this is here we need to pay attention, because the thing is what, whenever we are going for the Raspberry Pi is giving you a many different kind of an GPIO pins. Okay, so that time whenever you are programming the Raspberry Pi, that time you need to understand which pins you want to use, whether you want to go for the Broadcom pins or the onboard pins. Okay, so I will explain you how we are going to be decide and when to which pins we need to mention in a program and all. Okay, and which includes the ARM compatible central processing units. So on Raspberry Pi they are using the ARM processor and on chip graphic processing unit like GPU and the video core 4. Okay, if you can see the speed of this CPU speed ranges from 700 megahertz to the 1.2 gigahertz for Pi 3. Pi 3 in short we used to call as in a Raspberry Pi 3. We used to call it in a Pi 3. Some many people they used to call a Pi 3 as well. And on-board memory range from 256 MB to 1 GB RAM. So you can see the speed and all. It's really good. Along with that, secure digital, that the SD card is available and are used to store the operating system and program the memory in the either SDH or the Microsoft SD size. So you can understand, if you want to use the Raspberry Pi, there is the SD card socket. You need to insert the card, and you need a, like, that is a flash controller memory. You can install the Raspberry and operating system on your Raspberry Pi. I'll let you know what is in the Raspberry operating system and how to install that operating system on your Raspberry Pi. You only simply just flash that operating system on. It's freely available. You need a small SD card. You need to just flash it on that SD card, and that card you need to insert in the Raspberry Pi, and your Raspberry Pi is ready to use. Okay. So the most boards have between 1 and 4 USB slot, HDMI and composite video output, and 3.5 mm phono jack for the audio. Lower level output is provided by the number of GPIO pins which support the common protocols like ISQT. Now the B model have the 8P8C Ethernet port. So listen, every version is giving you a different kind of features. So if you're looking from 0th version to the any other version, you will get a many different flavors and the features as well. So right now we don't have that much time to discuss, but at the end of this presentation, we'll shortly discuss which are the features which are available from 0 to the now one. Okay. Now, which operating system you require if you are using the Raspberry Pi? The foundation provides the Raspbian operating system. So that it's a Debian-based Linux distribution for download, as well as the third-party Ubuntu, Windows 10, IoT Core, then RISC OS, and specialized media center distribution. So so if you are using a Raspberry Pi, you will get a lot of different flavors. Apart from that, here the foundation provides you the Raspbian operating system. It promotes the Python and Scratch as a main programming language. Obviously, after that, once you install the operating system, you need to go for just program that particular device or the board. Okay, so that time here they promote you the Python and the Scratch as a main operating programming language with the support for many languages. The default firmware is closed source, while an unofficial open source is available. So there are some files and the sources are available online. Some are the free one and some are, for some you need to pay. Now, if you can see the hardware, on this hardware you will get a RAM, then input-output devices, the CPU, the USB hub. You can connect your Raspberry Pi to the internet through the Ethernet to the internet and the USBs. Okay, so 2 and many USBs are available. Now, okay, so this block diagram depicts the model of A plus and B plus. Model A plus and the Pi 0 lack the Ethernet and the USB hub component. Whereas if you can see, the Ethernet adapter is internally connected to the additional USB port. In a model A plus and the Pi 0, the USB port is connected directly to the system on chip. So you can see this SoC. So that is system on chip. You can see that USB port on the Pi 1 model and on the Pi 1 model B plus and latter model USB or the Ethernet chip contain 5-point USB hub, of which 4 ports are available, while Pi 1 model B only provides the 2. So again, as per your requirement, you can select a particular Raspberry Pi, because as I said that every version give you the different kind of features. Okay, so on Pi 0, the USB port is also connected directly to the SoC, but uses a micro USB OTG port. Okay, and nowadays we as a people, we used to go for this version only. Another important thing about this Raspberry Pi, the processor. On this Raspberry Pi, the processor is the Broadcom BCM2835 processor. It is used in the first generation Raspberry Pi and is somewhat equivalent to the chip used in some first modern generation smartphones. Okay, and its CPU is an older ARM V6 architecture, which includes a 700 megahertz ARM 1176 JZFS processor. and the video code for graphics processing unit, that is GPU, and the RAM. So we need to understand this configuration details, because again, IoT, whatever the IoT application, all the IoT devices are the configurable. Means you can configure, you can extend, you can just extend your levels as well in a IoT. So that is the freedom here you are getting in IoT. So that's why if you want, if the particular processor and all, or the particular platform is not comfortable, you have another option as well. Each platform is having some limitations and the advantage as well. So you can see here we have already discussed the different levels as well. So it has a level 1 cache of 16 KB and a level 2 caches have 128 KB. So this level 2 cache is used primarily for the GPU, and the SoC is stacked underneath of the RAM chip. So only its edge is visible. So you cannot immediately see the particular device. So it's immediately below the particular RAM chip. Okay, so the Raspberry Pi 2 uses the Broadcom BCM2836, whereas Raspberry Pi 3 uses the Broadcom BCM2837. Again, if you can see the configuration details, it may vary. So you can decide as per the performance of that particular device. So I don't want to go in all detail which configuration detail. You will definitely get all the details about this configuration details about the Raspberry Pi on the official website, or I'll also share this presentation with you all. The next important thing is the RAM. The Raspberry Pi 2 and the Raspberry Pi 3 have a 1 GB of RAM. The Raspberry Pi 0 and W have the 512 MB of the RAM. For the study purpose, basically, we suggest you can go for the Raspberry Pi 0, which basically nowadays students are using the Raspberry Pi 0 version, and it's more comfortable one. So you can perform your all assignments on this 0th version as well. Okay, so the model A plus and the Pi 0 have no Ethernet security and are commonly connected to the network using the external user supplied USB Ethernet or the Wi-Fi adapter. So this is one more thing. If you can see on the Arduino board, we don't have the Bluetooth or the Wi-Fi adapter, whereas here you are getting the Wi-Fi adapter. So you can connect your device with the help of this Wi-Fi adapter as well. Now you can see here on the model B and B plus, the Ethernet port is provided by the built-in USB Ethernet adapter using this chip. And the Raspberry Pi 3 and 0, like the W version, are equipped with the 2.4 gigahertz Wi-Fi 802.11n. So this is obviously the standard Wi-Fi standard. Okay, and the Bluetooth 4.1 will give you the 24 Mbits based on the Broadcom BCM. Again, here we are using the Broadcom BCM 4348. Okay, it's a full Mac chip with no official support for monitor mode, but implemented through the unofficial firmware path changing. And the Pi 3 also have the 10 to 10 by 100 Ethernet port. So here also I would like to say that if you can see what we can say that if you want to extend, if you want to just in future, if you are looking for maybe your scope of your system is going to be changed, so that time these things are really important. Now the peripherals, the Raspberry Pi may be operated with any generic USB computer board and the mouse. It also be used with the USB storage, USB MIDI converter, and virtually any other devices or the component with the USB capabilities. Other peripherals can be attached to the various pins and the connectors on the surface of the Raspberry Pi. So we have a lot of many different GPIO pins which are available through which we can connect. On the Raspberry Pi, you will get a video capabilities as well. So video controller can emit a standard modern TV resolution such as HD or full HD, and the higher or the lower monitor resolutions, and older standard like CRT TV resolutions. So these are the video capabilities. And now, yes, so this is I would like to share with you all. If you can see Raspberry Pi 1 model A from the Raspberry Pi 0th model, which kind of features they are giving us. So if you can see here, just a second. So if you can see here, we have the Raspberry Pi 1 USB 2.0 port is available, or how many ports are available you can see here. Then the Ethernet Pi 1 model A is not giving you the Ethernet slot, and again for 1 A plus is also not, you will not get. And you can see here Raspberry Pi 1 model B plus, B again the Wi-Fi, which is not available in model A. Then A plus is also not available, where you will get model B, you will get a Pi 3. Under Pi 3 you can see 802.11n. So you can connect your Pi with the help of this Wi-Fi model. Okay. And yeah, audio in, audio out is again available. Then video in, video out is again available here. And storage, yes, SD card is, if you can see, many different SD card available, whereas if you can see in case of Raspberry Pi model 1A and B, only you have to insert the SD card, whereas other will comfortable with a micro SD card. Okay, so that SD card you need to just what we can say, just flash the operating system on that SD card and just insert that card into the Raspberry Pi. And once you connect that Raspberry Pi through your any monitor, you can immediately start your Raspberry Pi. Yeah. So this is all about the different flavors of the Raspberry Pi. And yes, these are the different operating system. You will get a lot of different Linux flavors over here. So Ubuntu Mint, Snappy Ubuntu Core, Windows 10 IoT Core, and Pinate, RISC OS, and many more. Okay, so you have a lot of different options which are available here. Now, operating system. For any particular device, the operating system is very important. Right now we are discussing about the Raspberry Pi. So here this Raspberry Pi Foundation recommends to use the Raspbian operating system, and it's a Debian based Linux operating system. So another third party operating system available via official website include the, so if you are looking for another like flavors, you will get on the official website. And specialized distribution for the Kodi Media Center or the classroom management. So those who are actually or the officially for a corporate purpose, if you are looking for, you will get further details on the official website. So these are some Linux based operating system which you can see on my screen. Arduino things, then Arch Linux, open source, then Fedora and Kali Linux and all. So these are the flavors of the other Linux, other operating systems. RISC OS Pi, FreeBSD, NetBSD, and all. Okay, now I just want to skip some slide because I want to cover. Yeah, just a second. Give me a second. Let me check. Yeah. So here these are some snapshot of all the versions of the Raspberry Pi. If you can see Raspberry Pi 0th version, you can see micro USB is available, micro USB available, GPU. CPU, GPU, Broadcom, BCM 8235 is available. 0th version give you the micro SD card, where there are some versions like A and I guess A plus or B. They will they'll not allow you to go for micro SD card. HDMI out is available. 40 GPIO pins are also available. Yeah. So this is, if you can see the next snapshot of this Pi model A, you will get another some features over here. Okay, just a second. So I'll just switch with the next slide because these are some snapshot of for model B, then B plus, then 2B, and we have already discussed what actually the particular model is giving you. Okay, so yeah, the other accessories, you will get a camera. If you want, you can directly connect the camera to your Raspberry Pi. The JERD board, then infrared camera, then hardware attached on the top. If you want to, these are some other accessories which are available. You can purchase it from any particular website online. Online you can just order it. Okay, so these are the accessories. Then the other development boards. So you can see here Asus Tinker board is again available. BeagleBone board is available. Then Banana Pi is available. Orange Pi is available. Ordinoid is also available. This will give you the another few the different feature which are not available with the basic like standard Raspberry Pi features. Okay, so apart from that, this is again I have clicked some. So these are some the pictures of this different Raspberry Pi. This is the Tinker board. You can see the basics and the difference one. And so if you're going to be compare the Raspberry Pi versus the Tinker board, you can see the processor they have used. Here we have used the BCM Broadcom processor, whereas if they have used a quad-core processor, and it's a benchmark score. If you can see, it's almost 2 times faster than the previous one. They are giving you the 2 GB RAM, and Raspberry Pi 3 model will give you the 1 GB RAM. So again here, if as a study purpose, if you are looking for like any IoT kind of an applications or any assignments, if you want to use, I would like to personally suggest you go with the Raspberry Pi, because study purpose is really best. And along with the Raspberry Pi, we have another option which is again really famous and available, is nothing but the Arduino board. Then we have a Blackbone, BeagleBone Black is also available. It's also having some own limitations and all, but yeah, today I don't want to cover the other platforms here. Yeah, so just give me one more second. I'll share my screen with you all. So I would like to explain you all the different other boards which other pins are available which you can use whenever you're going for Arduino or the Raspberry Pi. Which are the different pins are available and which you can use over here. Okay, just give me a second. I'll share my screen again. Okay, my screen is visible to you. Is it visible?
Yes, ma'am.
Yeah. Okay, so here now I would like to share you the basic interfacing using the Raspberry Pi. So first of all, we need to understand which are the different components or the architecture of the Raspberry Pi. You will get the input output devices, along with the CPU and the memory, and the Raspberry Pi embedded system architecture. If you can see here, only the difference is what here as an input basic computer architecture, we have an input device, output device, CPU and a memory, whereas in case of a Raspberry Pi you will get a sensor, actuator and the memory, for which we are going to be use a SD card, because Raspberry Pi is also having a small enough of memory. Okay, so if you are buying a Raspberry Pi, it's having some limited memory, not a huge amount of memory, but definitely if you are going to be connect your Raspberry Pi with to the internet, you can store your entire data on your cloud as well. So we cannot say that this is one of the limitation that is Raspberry Pi is having a very less amount of memory, but it's having enough amount of memory. And if that memory is not enough, you can definitely upload it on the cloud as well. And the sensors and the actuator. Okay, now I would like to start with the simple IoT architecture. So if you have a Raspberry Pi or the Arduino board or any other BeagleBone or any other platform, this is the actual your platform or the device. We use to connect the sensors and the actuator to the board. Is having the board is also having its own memory, or you can upload the data on the cloud as well, and through which actually the user share the information, collect the data or analysis the data. So this is the simple IoT architecture. So we'll go one by one. The first very famous term in IoT is nothing but a sensor. Sensor or the detector is a device that is actually collect the data, okay, which actually capture the details. So we have many sensors are available in a market, like heart rate sensor, the temperature sensor, the ultrasonic sensor, PIR sensor, and many more different sensors are available. When we call as a particular device as a sensor who actually sends the information, collect the data. Okay, so the input parameter can be different like a light, temperature, humidity, pressure, etc. But the output is generally the human readable or electrically monitorable. So what you are getting once the sensor is capture the data, how you are going to be read that data. That is again a more important thing. So sensor definition. So according to Oxford Dictionary definitions, a device which detect or measure a physical property and record property and records indicate or otherwise responded. Okay, we respond when we give a response. Obviously, once the sensor will collect the data, you're going to be you need to understand the data and you need to show some action. And that action, who will give you the action? Yes, the actuators are available who will show you that particular action. So meaning of sensor, as per the Wikipedia, a sensor is an object whose purpose is to detect the event or changes in its environment and then provide a corresponding output. Okay, so we'll discuss many different sensors as well. And sensor is classified based on the various aspects. So the application based sensors like industrial sensor, automotive sensor, then output based sensor like resistive output, differential output, voltage output, or the parameter sensing based like light, temperature, sound, gas, and all. Okay, so these are the different types of sensor. And nowadays commonly sensor which we are using in a like in our education or in a corporate field also, the people they used to go with this light sensor, temperature sensor, proximity sensor, pressure sensor, gas sensor, speed sensor, motion sensor, flex sensor. Many different sensors are available. Now, sensor who actually they capture the information, whereas the actuator is a component of a machine that is responsible for moving or controlling the mechanism or the system. The actuator requires to control signal and the source of energy. So what actually we used to give? We used to give the voltage to the actuator, and whatever the feature of that particular actuator, the actuator will perform some action. So these are some listed actuator like LED, RGB LED, buzzers, servo motor, DC motor, and relays. Okay, so because they actually shows you some information, show you some action. So these are the actuators. Now, yeah, and these are some I've taken. So these are some sensors which you can see. So here the gas sensor is available, PIR sensor is available, then what you can see is this ultrasonic sensor is available. Okay, so these are the different sensors. Now, yes, if you can see, we have today we have also discussed the different models, Raspberry Pi models. So you can see here model A and B, and model A plus, B plus, and Pi 2. So if you can see, the pins which are available under model A and B are the limited one. Whereas if you can see the another model which you are giving you will get a 40 pins over here. Okay, I'll explain you which are the different 40 pins. So this is nothing but a this is a pin diagram, GPIO pin out diagram. So general purpose input output pin diagram. Why we require this pin diagram chart? Because if you can see, we need to connect different sensors and the actuator. So that time we need to understand which are the output pins and which are the input pins, so that we can connect the sensors and the actuator to the Raspberry Pi. So you can see here on this in this pin out diagram, you can see there are some pin which are available. They are labeled inside the square bracket, rectangular bracket, whereas some names which are available outside of this red rectangle. Okay, so so you can see total how many GPIO pins are available. 40 pins are available. So if you can see, the GPIO board option specifies you are referring to the pins by number of pins, the plug, like in that a number of printed board, like example P1, and the middle one diagram below. Okay, so as I said you, there are two different modes you can select. Either you can go for board mode, or you can go for the BCM mode. Okay, so the you can see here, the if you want to go for the BCM pins, okay, if you want to go for the pins, So the option is that you are referring the pins by the Broadcom SoC channel, and the number of these pins number after the GPIO in a green rectangular. So the outer ones we can say that these are the BCM pin, and the inner ones are the board pins. Why we need to understand the BCM pin and the board pin? Because whenever we are programming the Raspberry Pi, that time we need to mention a particular sensor we have connected to Broadcom pin or the board pin. So that time we need to understand ki yes, this here we are trying to connect with the board pin or the Broadcom pin. Okay, so that's why we need to understand these two modes. Unfortunately, the BCM numbers change between the version of the P1 model B. Okay, so again, if you can see, the depending on the version of a particular Raspberry Pi, again this Broadcom BCM pins number supposed to be the change one. So this is all about the different GPIO pins for the Raspberry Pi. And yes, here also, in short, I know that you all are expert in the you may have already tried with the just blinking the LED on the Arduino board or the Raspberry Pi. So right now you can see here, this is the LED. LED is having two legs, anode and cathode, and you can connect this LED through the breadboard. And breadboard is having the horizontal and the vertical lines, which you can see on my screen. And this will let you know how actually voltage passes from one lane to the another lane. Okay, so whenever you have many different sensors or the actuator which you would like to connect to your Arduino or the Raspberry Pi, that time definitely you can use this breadboard. So here you can see how actually voltage flows horizontally and the vertically. Yeah, we also have some resistors which actually resist the voltage, and there's some jumper wires which actually we require. Nowadays I know many institutions, they are working online, and that time we need to show some hands-on, we need to give hands-on training to the students that we want to give the actual how actually this will happen and all. So today, after once I'll finish, I'll show you the some online platform where you can show the simulation of IoT, like sensors and the actuators. So here I would like to show you if you want to start, obviously you can go with blinking the LED. So this is one of the example you can see here. This LED I have connected to the Raspberry Pi, and one leg I have connected to the ground. Another leg you can connect anywhere, any input output pin. We have a 40 input output pins on a Raspberry Pi. You can select any one of them, and that's it. And you need to write a very small script that's supposed to be the you can see here. So this is a really small script, and you can see here, as I have mentioned, which pins you all are using, that you need to mention whenever you are setting a mode. So right now in my code I have a set mode as a BCM mode. Okay, so Broadcom mode I have selected. If you want to go for board mode, you can go for board mode as well. So GPIO, the pins which you are going to be used, initially you need to set a mode. For warnings, you can, it's an optional one line. If you want, you can avoid the warning. So you can make it as a false. Now I have connected that particular pin to pin number 18, so that you have to mention. So GPIO.setup 18 slash comma output. So again, if you are using a sensor and the actuator, you need to understand what actually the device will perform, whether the device will act as an input device or the output device. So here I am using the LED, that's why I am using here GPIO.out pin. Okay, and this is a very simple loop, while loop, where I'm trying to turn on and off the LED. Yeah, so if you want to fade the LED, this is one of the one more example which you can see here on my screen. If you want to fade the LED, you can also fade the LED. Okay, and yeah, so this is all about the Raspberry Pi, and this is a small example of the turning on and off the LED on the Raspberry Pi. Now I would like to start with today's afternoon topic about the MQTT protocol, because as per this FDP, we have decided that we are going to be discuss about the simulation of the different IoT sensors and the actuator. Okay, give me one more second so that I'll share my screen. Uh, Okay, before I want to start with the MQTT protocol, I would like to show you one really interesting kind of an simulation which I have prepared today. Let me share my screen. So I have a maybe how many of you are aware with the Tinkercad? Can you please let me know?
Yes, ma'am, we are aware.
Yeah, that's great. So here
Yes.
I would like to share you as Arduino board. One of the limitation of the Arduino board is not having the inbuilt Wi-Fi or the Bluetooth facility. So that's why today I would like to show you a very short and simple simulation. So here I'm using the ESP8266 module. Okay, I know that if you can see on my screen, this is my Tinkercad account, and this is the Tinkercad platform will give you the
Ma'am,
actual.
ma'am, screen is not shared.
Okay, I'm so sorry. Just a second. I'll share my screen again. Okay, now it's visible.
Yes. Yes.
Yeah. So here I would like to show you a smart simulation for Arduino board. Here, as I said, that we don't have the Bluetooth facility or the like Wi-Fi module inbuilt on the Arduino board. So that's why I would like to show you the ESP8266 simulation. And what is the aim of this simulation is what I would like to do. I would like to just capture the temperature using a temperature sensor. And after that, what I would like to do, after capturing the temperature sensor, I would like to just send it on a cloud. Okay, and there for after sending the cloud, obviously I would like to just showcase over there. We have a lot many different kind of online platform analytical tools which you can use over here. Right now I'm using the ThinkSpeak. Okay, so ThinkSpeak is again an online platform where you can visualize your data, you can show your data. So I will explain you about the ThinkSpeak as well. Initially, if you can see here, on this is my Tinkercad account and I'm using ESP8266. So ESP8266 is the Wi-Fi model. Okay, if you have an actual Arduino board with you, you only need to buy the ESP8266, which will give you the functionality for the Wi-Fi model, and you need a small connection for the same. Right now, I know we all are sitting at our home and we don't have the hardware. That's why I'm showing you the simulation on a Tinkercad. So what you need to do, you need to open a Tinkercad, you need to create the account, you just need to drag and drop the Arduino board over here. And this ESP8266 is not available. If you all people want this ESP8266, there are some circuits which are already prepared on the Tinkercad. You can directly use over there and you can just configure that ESP8266. Even though if you want to tinker my whatever the design assignment, you can tinker it. Okay, so right now you can see, even though you can change the name of your assignment, whatever you want to do. So right now we are talking about a Tinkercad ESP8266. Okay, and now so this is the ESP8266, and this is a warning, you need to close it, and I've already designed this. Yes.
You can hide that component bar so that screen will be enlarged, circuit will be enlarged.
So this will, okay, if you want, okay, fine.
Yeah, and take it at the center.
Yes, that I can do it.
Yeah.
Now it's visible.
Yes, great.
Yeah, thank you so much, sir. Now here, this is my ESP8266. Okay, so this ESP8266 is having some pins. If you can see, 1, 2, 3, 4, 5, 6, 7, 8 pins are available. And here, this ground pin I have to connect it to the ground. Okay, and we have the transmission pin and receiving pin. If you can see, transmission pin I have connected to the here to the receiver of the Arduino board, the cross. So for example, ESP8266 transmission pin, you need to connect to receiver of your Arduino board, and receiver of Arduino board you need to connect to the transmitter pin of the ESP8266. Whereas ESP8266 requires the 3.3 voltage. But if you know that, maybe many of you are aware that this will give you the 5 voltage. Okay, 5 volt voltage. So I need a voltage divider. So that's why I have divided my circuit. So I have used over here voltage divider. So I'm dividing the voltage and then I'm giving that voltage to this receiver pin. Okay, So this is all about ground, transmission pin, receiver pin. Then we have two enable pins. If you can see here, these are the enable pin and the reset pin, which I have shorted over here. And we also have the 5 volt voltage. So here I have connected to here Arduino board 5 voltage. So this is simple, very simple connection. Apart from that, what I would like to do, I want to control. I want to program this temperature. Okay, so that's why I have used a temperature sensor over here. You can see here this temperature as a sensor is also having the 3 pins, the power pin, and the black one is the obviously the, if you have any background of the embedded system and all, basically black pin and black jumper wires we use for the ground connection. Okay, so that I have connected to the black jumper wire I've used to connect the ground. Red one I've used for the VCC, and the third one, this is, if you can see here, this I have connected to the analog pin, A0 pin, because temperature sensor will require the analog pins. So that's why you can connect anywhere, A0 to A5, you can use any different pins for connection. Okay, so this is all about this circuit. Now what I would like to do, I would like to capture the first data. I would like to capture the temperature, and then I would like to share that temperature or send it on the cloud. Okay, so this is one of the platform. You can see here, this is the ThingSpeak account. So my screen is visible. I have only shifted with the tab.
Yes.
Yeah. So here you can see ThingSpeak for IoT projects. Okay, so data collection in a cloud with the advanced data analysis using the MATLAB. So what you all need to do, you need to create an account on the ThingSpeak. So for example, I have my account on this. So I'm not creating again. It takes some moment. Okay, so I need to sign in. You need to enter mail ID and whatever the account credentials you require. So just a second. Let me enter my password. Yeah. So what you need to do, first of all, you need to create a ThingSpeak account on your ThingSpeak account, as well as if you don't have the Tinkercad account, you need to create a Tinkercad account, and this is the circuit design which you need to design. Okay. Once you're done with this ThingSpeak account and the Tinkercad account, you need to connect both the account. How you are going to do this connection? It means that you need to connect to the cloud. Okay. So for that, first of all, I'll create a channel. What is meant by channel? So for example, we in IoT protocols, we have discussed the request response protocol. We have discussed the publish subscriber model and all. Okay. So here what I need to do, I need to create a channel first. So till date, I have created many different channels, and I'm using a free ThingSpeak account. So that's why they will not allow me to create one more channel. And today, because we have a limited time and all, so I don't want to create a new channel, because if I'm going to create a new channel, you can see they will give me the warning. So a free license is limited to the 4 channel. You must delete the existing channel. Okay, so if you want, you can delete any one of this channel. So right now I would like to show you the channel which I have already prepared. If you are using this ThingSpeak for the first time, what you all need to do, you need to create a ThingSpeak account first. Second step is what? Create a channel. So you need to click on the new channel. Once you click on that new channel, you will get a new page. Okay, so you can see here, this page you can see on your screen. Once you create a new page, under channel setting, what you need to do, you need to give a channel name. What is the aim of my today's task? I want to just capture the temperature, and I want to just showcase it on the ThingSpeak. Okay. So what you need to do here, you need to give a name of the channel. So I have a given name, temperature 2021. Okay, so this is the name of my channel. If you want to add the description, you can add a description as well. I have not added the description over here, but you can add it. Then the field one. So right now you can see these many fields are available. Right now I'm only capturing the temperature, so I have created a field one over here. Okay, so you can see a field one, and you can give the name of the field as well. So my field one is the temperature, and you need to just click on this checkbox. That's it. Other details are not a mandatory, so I have directly click on the save channel. Okay, so I have saved my channel. You can see my channel is created, my channel is updated or they created. Then temperature 1 underscore 2021 is my channel name. You can see, as we have discussed, each is having unique ID. So this channel also is having the unique ID. Okay, and this is the private access. Okay, and yeah, so once we create a channel, what you need to do, as per the aim, whatever, for example, if I'm going to execute, if I'm going to simulate this simulation, if I'm going to start on the simulation and I'm changing the temperature, immediately I want to see the reflect on my ThinkSpeak account. So what do you need? You need to copy the write API key. So here you can see the two different APIs, write API key and the read API key. Right now I only want to share the data on the cloud. Okay, so that time I want to write something. Okay, so that's why you can use this write API key. What do you need to do? You only need to copy this key, Control C, and you need to paste here inside the code. So this is the code which I have prepared for this assignment or for this task. You can see here under yeah. Can you see here? Can you see my code, sir?
Yes, ma'am.
Yeah, so under string URL, you can see here I need to just paste my write key over here. Okay, so I have pasted my write key API over here. Why we need to go for the write key? It's up to you all, because if you want to, which kind of a task you want to perform, whether you want to write or you want to read. Okay, so for example, if you want to turn on and off the LED, so obviously, may I know which kind of API key we need to copy? Yes. So you can try, you can check and let me know, because this is also we can do even though through the mobile application. So for example, if you're using any mobile phone and through the mobile phone, you want to turn on and off the things, that also you can do with the help of this Wi-Fi model. Okay. So what I'm trying to do here, I'm using the API key, write API key over here. Along with that, you can see here, I have what I have written here, ampersand field 1 equal to 0. As in a channel, in my channel, I have used only one single field. So that's why ampersand field 1 equal to 0. Okay, ampersand field 1 equal to 0. If you have a more than one field, you can mention it here only. Okay. So this is, I'll first show you the simulation, then I will discuss this code as well. And you can definitely show to your student because it's very interesting. I'll click on the code. So this will hide, this will hide my code. And now I'll start the simulation. Okay. Once I'm going to start the simulation, I'm going to click on the code over here. Okay. And I just want to fit my, yeah. So now this Arduino is fitting to my screen, and I'm going to click on my serial monitor. Okay, whenever you are programming our ESP8266 module, we require some 80 commands. We'll discuss all the 80 commands. Let me first show the simulation, then I'll explain you which are the 80 commands we require if you want to use this ESP8266. So you can see here in a serial monitor. Just a second, let me just maximize the screen. So you can see here in serial monitor, I've executed some 80 commands. So 80 plus CWGAP for forming the initial connection. Then for starting the communication, CIP start. Then you can see here 80 CPIC send for sending the files and all. Okay. So there are some commands, 80 commands, which we need to execute if we want to form the connection or send any particular data on the cloud. Now, as we have discussed, we want to just share the temperature on the ThinkSpeak. So here what I'm trying to do right now, if you can see, this ESP8266 already started sending the data. You can see here in a serial monitor, I have mentioned ESP8266 send data to the server. So right now they have already started sending the data. So right now you can see here the temperature is how much is the temperature? I can see here it's at 24. Okay, so field 1, you can see here 0.024.70 is the temperature. So after a particular delay. Why after a particular delay? You can continuously, you can also send the data continuously as well. But right now in my code, I have added some delay to understand the effect of the temperature change. Now I'm changing my temperature sensors temperature. If you can see here, I have changed right now, and you can immediately see the temperature change effect in a serial monitor. If you can see now, it's showing me it's 93. Can you see here? Participant, can you please let me know? It will be great for me if it is in a visible or not.
Yes, ma'am.
Yeah, thank you. So here field 1 equal to the temperature, the updated temperature you can see in a serial monitor. This is about the serial monitor, but this is not the aim of today. We want to just display the same over here. Okay, so just a second. Just a second. Here under private view, you need to click on a private view, and just a second. Yeah, you need to click on a private view, and you can see I have prepared the ThingSpeak account or the channel on the date 14. Wait a second. Yeah, 14 September I have prepared this channel, and today is, you can see it's a 16. You can see here right now the temperature is, just a second, it's 93.06. Okay, so you can see here how this this temperature sensor will sense the temperature, and the ESP8266 sharing the data on the ThingSpeak. Okay, again I'm going to be change the temperature values. If you can see here, let me click on the code so that you can see. So right now you can see again I'm going to be change it to the, yeah, so it is 20 degrees centigrade, minus 20 degrees centigrade. So you can see here again I'm changing the temperature value. Again you need to go on the page, ThingSpeak page. You just refresh your page. So you can see here it will again show you the updates, but it takes some time to update. So right now if you can see here, it's yeah, it takes some time. Let me check whether the our ESP8260 they have already sent it or not. So you can check it from here. So right now you can see here now it's field number 1, and the temperature, current temperature which they have already sent. So now you can again update your ThingSpeak page so that you will get an update over here. Yeah, so you can see here the updates. Even though if you want to add some widget, you can add widgets as well by clicking over here. So you can add widgets. I've already added the widgets, so if you want you can also add the widgets as well. So this is how you can just create a channel on a ThingSpeak, and you can reflect the your updates on the ThingSpeak. So this will give you the analytics and all. Apart from that, how we are going to be program this ESP8266 is more important. Okay, what I'll do, I'll stop sharing and I'll share again so that I'll explain you which are the different commands which we require. Okay, to start the simulation of, or for example for programming the ESP8266. Okay, so just a second. Shortly, first of all, I'll like to just brief you about the program which I have prepared. If you know the basics of computers and all, I need to mention the SSID, I need to mention the password, and for where I'm hosting, that also you need to give the details over here. So I'm hosting on the ThingSpeak, the HTTP port that's supposed to be the 80, and after that the API key I have used over here, the right API key. Apart from that, I need to set up my ESP8266. So this is very important because here initially for setting up the ESP8266, there are many different options, whereas I'm using here the 80 using the 80 commands. So this is the serial communication 11520 is a standard rate. Then after that, yeah, we need to use some commands. Okay, so which 80 commands? Let me stop sharing and I'll share again. Wait a second. Okay, my screen is visible to you all participants.
Yes, ma'am.
Yeah, thank you. Yeah, so we were discussing about the 80 commands which we require to program our ESP8266, and ESP8266 is a Wi-Fi model. So there are many 80 commands that can be used to program this ESP8266 Wi-Fi model, and some of I have listed over here. So the commands which we need to follow the 3 steps simply. So first of all, forming the connection. So 80 plus CWJAP is equal to, you need to mention the SSID and the password, which will allow you to connect ESP8266. So this connect the ESP8266 to the specified SSID and the 80 commands. In my code, I have already given the SSID and the password. And if you can see the next step, what you need to do, another command which you require to form a connection to the server. Okay, so here right now you need to mention the which type of connection you require. Today we have already discussed that there are 2 different type of connections. Either you can go for the TCP or the UDP, it's your choice as per the end user requirement, and the IP address or the host ID and all. So that also you need to mention to which server you want to connect. So that details you need to mention using this 80 plus SIP start. And another command which you need to use, the command which actually really important, because this command we use to send data. Okay, so ESP8266 will send the data to the server. So that time 80 plus SIP send. Okay, and right over here I have mentioned the 4 byte. So set a data length which will be sent, such as a 4 byte response. So they will receive a 4 byte and then send OK. Here in case of the ESP8266, what we are trying to do, we are trying to just send data on the cloud. So whenever we are sharing a data, whenever sending any data, we require, so obviously it contains a particular packet. So as a basics of computer networks, we know that the packet is having its own additional information as well, like a payload value, the data value, the data length and all. So here in my in code, I have also calculated the length of my data as well. I'll show you here. So wait a second, let me show you. Yes, so here you can see I have first used this for forming the connection. I have sent the SSID password, then connection host, this ESP8266 connect to the server as a TCP, and after that I've added some delay to only to see the effect. Then I've calculated, then I've sent the details, and as I'm using a temperature sensor, so here I'm using the, just a second, I've just converted the what are the temperature which I have listed in the proper format. So you can see here. Then SIP send will send my data on the cloud, and yes, that's it. So yes, so this is all about the ESP8266, and what I'm trying to show you all. In IoT, we can capture the real-time data with the help of this kind of simulators and all. We can simulation that how actually real-time we can capture the data, and we can just present it, or we can showcase, or we can apply on analytics on the same data. So ESP8266 is one of the Wi-Fi model which we can use over here, because obviously the Arduino board itself is not having an inbuilt Wi-Fi feature with them. So now I would like to start with the next topic, that's supposed to be the MQTT protocol. So give me one more second so that I'll share my screen. Okay, till that time, if you have any doubts, you can ask me. Any doubt regarding this ThinkSpeak topic or the ESP8266?
Ma'am, could you please share the code so that we can also try?
Yes, sure. You can, even though right now also you can try, because if you have any doubt, immediately I can resolve it here only. Let me just a second. What I'll do, I'll share you I'll paste the Tinker link in a chat box. Give me a second. So here is my Tinker link. What you need to do, you just click on that link and you need to click on the Tinker, and that's it. And Yes, then you will get entire code and all. Wait a second. So in the chat box, I guess, yeah, messages. Yes, I have sent my Tinkercad link in the chat box, so you can access it. You can try it, and you can, if you have any difficulty, you can ask me as well right now. So
Okay, thank you, ma'am. Thank you.
yes. So this is all about the ThinkSpeak and the Tinkercad. And right now we just now we have discussed about the ESP8266. Now the second, I don't have I'm not going to be show you immediate simulation, but right now I just want to give you the idea how the MQTT, because another protocol which I would like to discuss today in detail is about the MQTT protocol. Let me share my screen. Mm-hmm. Yes. My screen is visible to you all.
Yes, ma'am.
Yes, ma'am.
Yeah, thank you. So now the second protocol which I would like to share here is the MQTT protocol. It's a message queuing telemetry protocol. And here what I have decided, I would like to show you that MQTT protocol is using the publish subscriber kind of in a model. So here I would like to show you, I just want to just capture the temperature data. Just now we have shared the data on the cloud. Now I would like to show you with the help of MQTT protocol. I want to publish the data, and someone or the subscriber need to subscribe that topic, and they will get the real-time information. Okay. So here the main objective, what I have decided to understand how the sensor data will get published and the subscribe, and to learn the various clients and the brokers available in implementation. So here, whenever we are talking about the MQTT protocol is having a message broker and the subscriber. Okay, so obviously the broker role is really important in this protocol, and that's why we have the many different options in MQTT brokers. Okay, so we'll discuss all the different brokers over here. So there are several where we can use this MQTT. First of all, what is the application of this MQTT? And if you're going to see the Facebook Messenger, they have used the aspect of MQTT in the Facebook Messenger for online chatting. However, it is unclear how much MQTT they have used, but yes, they are using the MQTT in the chat box. And Amazon Web Services announced the Amazon IoT-based MQTT in 2015. Adafruit launched a free MQTT cloud service for the IoT experiment. So the people, those who want to try as an experiment purpose, they can use this free version of the Adafruit. Okay, and they can try this. So again, Azure IoT Hub uses the MQTT as its main protocol for telemetry messages. Basically, one more good application is the power monitoring, then lightning control, gardening. So these are the different applications of the MQTT. Now, I would like to shortly just revise some things about the MQTT. I know we have already discussed the MQTT, but MQTT is the ISO standard, and this standard is using publish subscribe model. We have two models, publish subscriber, and the another is request response. So this is a publish subscribe based message protocol. It works on the top of the TCP/IP protocol. Here, the publish subscriber messaging pattern requires a message broker. An MQTT system consists of a client communicating with the server, often called as a broker. So it's very important now. This broker role is really important in this protocol. What actually broker will do? Broker will maintain all the different topics. I've already given you, I guess in a recent talk, we have already discussed key. For example, if I'm looking for the hostel, I'm going to be contact the broker. Broker will maintain all the different topics, like if someone is looking for PGs or someone is looking for the hostel or someone is looking for the flat kind of a thing. So these kind of topics are available with the at the broker. And if I'm a student and I'm looking for the particular topic, I need to subscribe that topic. Okay, so same, this is what we are trying today here. And today what I have decided, for example, I would like to just capture the temperature from various places in Pune. I'm here in the Pune and I'm living in a Kothur, and I want to capture some temperature details. So I have plotted the temperature sensor in, throughout the Pune everywhere and many different locations. And I'm going to be capture the temperature, out of which I am only interested in the Kothur temperature. So MQTT, how actually they store the topic. So this information is organized in a hierarchy of a topic. So for example, Pune, then slash, then Kothur, then slash. For example, as I'm from MIT, I would like to check the temperature of the MIT. So likewise, the topic hierarchy is going to be maintained at the MQTT side. And this is going to be maintained at broker as well, because broker is going to be maintain the different topics. Okay, and yes, the next page I'll show you. So this is the public subscriber model. Again, here also we need to follow some steps like forming the connection, send a request to connection. So here we have many different messages like connect, disconnect, publish, and the subscribe. So the first step which we need to follow, that is forming the connection. So connect method to the broker or the subscriber also need to connect with the broker. So both the connection. Then if the broker is available, give you the correct acknowledgement for the same. Then the client, for example, many different clients, there will be maybe single client, or there may be many different clients. So they will just publish the data. So the broker will get all the published details at their end, and broker will maintain such a kind of a topic list. So they will create a topics as per the interest of the customers or the clients, and client need to subscribe that particular topic. So messages in MQTT are published on the topics. Topics are treated as a hierarchy using a slash as a separator. So as I explained you, like Maharashtra, Pune, then Kothur, then MIT, likewise. Okay. So this is an example. So like sensor, computer name, then temperature, then hardware name, and so on. For example, you can use the wildcards as well. So you can see here the plus can be used as a wildcard for the single level of hierarchy, where if you have a multiple hierarchy, you can go for the hash. Okay. So yeah, so these are the different messages. Now, another very important step of this MQTT, if you want to install the broker on your system, there are many different options. We'll go one by one. The important step is to make sure the MQTT broker setup and ready to receive and send the messages. MQTT broker can be used in the following ways. So obviously we require the broker, because broker is going to be hold all the information. So what we need to do, we need to first of all, the first option, you can use any existing broker or the local broker in your network, or the any intercept. So you have three different options. Either you can go for an existing broker, or you can use your own broker. You can, for example, I'm sitting in a particular LAN, and this is my computer, and I'm making my computer itself as a broker in a LAN. Okay. So that is again possible. You can make your own broker. You only need to give the IP address of that system. Okay. So that may be your broker, but you need a lot of steps you need to follow if you want to make your own broker at your local network. Other way is what the existing broker, the free brokers which are available in a market, like a Mosquito broker, then the Hive broker, and Eclipse brokers. Okay, so all these different brokers are available. You can also go for that broker as well. Okay, so here the new broker on the local network using a PAHO Python library. Okay, so if you want or you will wish to establish an MQTT broker on your development computer using the PAHO Python libraries, so you need to install the PAHO library on your computer. Simply you need to open the command prompt. You need to just execute some PAHO commands and all, and then you need to install the MQTT broker, and then you can use the PAHO Python library. And that's it. Or if you want to go for your own local network broker using the Mosquito. So Mosquito is again a broker. So you will establish the MQTT broker on your development computer using a Mosquito, and the development computer connect the gateway through the local network page. So for that you need to just do some extra steps than the previous one, because the previous is there are some brokers which are already available, standard, freely available. But if you want to make your own broker, that is again another option. But that steps I have not covered in the today's presentation. But definitely we can do with local broker as well. Now Mosquito is an open source message broker, and that implements the MQTT protocol. Now, before using a following statement, what we need to do, if we want to just if we want to use a MQTT protocol, we need to import one library. Here what I have prepared two different programs. So one program, in my one program, I'm trying to just, I have one program that's supposed to be the publisher program, and I have another program that's supposed to be my subscriber program. So that subscriber maybe sometime it may be a broker as well. Okay. So right now, here I'm showing my subscriber is like a broker only. Okay. So I need one library that's supposed to be import paho.mqtt.client as a paho. So this is the library which I need to include in my program, in a Python program. So if you want to use a paho, you need to install first paho on the system. So what you need to do, you only need to open the command prompt, and you need to install the paho MQTT. But before that, you need to use a pip command. Obviously they will give you the error if the pip is not installed on your computer. So if you want to install the pip, you need to just execute the following commands like get pip.py. Once you execute the pip file, the folder will create, and after that you can just install the pip on your computer, and then you can install the MQTT paho. Yes, that's it. And after that, wait a second. Yes, so after that, yes, another thing is what, here we have installed the MQTT broker, and we have prepared two different files. One is the publisher, another is the subscriber. So then we need to form a connection to this from publisher to the subscriber. So publisher continuously publish the data. In our case today, I have considered that I am going to be capture the temperature. Okay, real-time temperature. So my temperature sensor, the DHT11 sensor, I'm going to be used over here. So DHT11 is my temperature sensor, which will capture the temperature, real-time temperature. Okay, and publisher will publish that real-time temperature. Okay, by preparing a topic. So publisher will publish that real-time temperature on that particular topic. Okay, and then subscriber need to subscribe the topic. Then the subscriber will get the particular topic details. So you can see here, if you want to be sure, want to form a connection, you can use this on connect method. There are different methods are available. On connect method, then on close connection, on publish, kind of publish for subscribe. Many different methods are available. If you want to show that the connection attempt was successful, you can check. Obviously, if you send a request for forming the connection, you need to understand whether the connection is formed or not, and that you can check with using this RC course. So like return course, like if you can see here, if you send a request for forming the connection using the on connect method, if you will get a 0 as a return code, it means that the connection is successful. If you receive a 1, so connection is refused. It means the incorrect protocol version or invalid client identifier, or the server is unavailable. Obviously, kind of an acknowledgement you will receive from the broker. Okay, and along with that, flags and the user data are normally used in case of this whenever we are transmitting these messages. Therefore, the script generally looks like you can see here: create a client object, callback function on connect. So callback function will make a call. Any questions? Yes, I'm so sorry. I forgot to ask you if you have any question, you can ask me. But let me finish the steps, and I'll come back to you. So after that, blind call, callback or callback function, and connect to the broker and start the loop. That's it. So continuously, what we are going to be doing? We are going to be continuously transmit or publish the data for the broker. Okay. So you can see whenever you are forming the connection, you are sending the client details. Along with that, the user data and flags and the RC. Basically, we avoid to go with the user data and flags. It's not that is not that much mandatory, but you can add that things as well. Again, we have the loop options as available. If you can see my screen, you can start the loop. You can start a loop for a forever. If you want a continuous loop, you don't want to just like every time you don't want to start on the stop the loop, you can go for loop forever as well. Okay, so these are the different, again, two methods which are the inbuilt method you can use over here. So publish and acknowledgement, you can see client program, they will form the connection, they will start transmitting the data. Before that, you require this connection. And yes, yeah. So this is the code. So initially you need to write a first publisher code. My screen is visible to you all. I would like to explain this protocol with the help of example.
Yes, ma'am.
Yes, thank you so much. So I would like to explain this protocol with the help of this small thing, example. So right now, as I said that I have considered temperature sensor, that is a DHT11 sensor. Okay, so I required I need to import the library for the same. So that's why I have used here import Adafruit DHT library. Along with that, I have used the MQTT. As I explained you, if I'm using MQTT broker, you need to import the library as well. And we have already installed the MQTT and the PAHO on our system. So that also you can import over here. Then the broker which you want to use. So as I said that we have the three options. Either you can make your own broker, or you have a other freely available broker. Okay, or you can see here you can use a Hive, Eclipse, or the Mosquito broker. So all these are the different options available. Right now in this program, I have considered the Hive broker. So broker is equal to broker.hive.com. So this is the through which I will get my broker. So this is the details about my broker. And then I need to execute some commands, not a commands, we can say these are some methods for forming the connection. If you can see, initial step is what? I need to publish some data, and where you want to publish, where you want to host it, that also you need to mention. So you can see here, you need to mention the client name, the data which you want to pass, and the flag and the RC. RC is nothing but the return code. Okay. So if the connection is formed successfully, you will get a 0 as an acknowledgement. If it is not non-zero value, obviously there is some error in your connection that you can identify. Apart from that, I'm using the DHT11. So this DHT11, you need to connect to your Arduino board first. And if you're connecting to the Arduino board, on which pin you have connected. So which pin you have connected DHT11, that you have to mention. So you can use this read retrieve method to collect the data, humidity and temperature data using the DHT11. And so here you will get a data, and we are storing this humidity and temperature. And now what we want to do, we want to connect to the client. So client2.connect broker. Then we are forming the connection. Then loop start. Under loop start, you can see here what I have mentioned, that I want to publish the data on a particular topic. So client2.publish MIT/temperature. So what I have mentioned over here, I just want to publish this temperature under this topic only. So the topic name you need to mention over here. So this is what I have mentioned, and under the and I want to display the temperature because I have whatever the information, what is the temperature values I'm getting, that I'm storing in the temperature variable. So that I have passed over here. And so here what this publisher will do, publisher keep on publish the data. Okay, I have also added some sleeping period so that I can understand ki, yes, this is the first of for the first time I've published this much data, and again after some delay you can publish the another data, and so on. Okay, so I've added some sleeping period over here, and this will keep so the publisher keep on publishing the data unless and until you are not going to be enter any key. This is what I have programmed. You can make your own program as well. Once you prepared your publisher, you need to write a program for the subscriber as well. In subscriber also you need to use the same broker. Very important. We cannot do that publisher is using another broker and subscriber is using another broker. No, you have to use the same broker. So in a previous code I have mentioned I am going to be use the Hive broker. So here also you can see here I have mentioned the Hive broker. So the rest broker I have commented. It's your choice which broker you want to use. As a study purpose, we can go with the freely available brokers. Then as this is the subscriber, this subscriber need to subscribe a particular topic. So in a publisher, I have already mentioned where I want to, on which topic I want to publish. So subscriber will mention the topic name, then only subscriber will get the details. And again, initially, if the subscriber want to connect with the publisher, initially form the connection, then they can get a message with the help of on messages and all. And again, subscriber will get all the details unless and until you are not going to be entered any keyboard keys. Yeah. So this is all about the publisher and the subscriber. And now, yes, so this is the screenshot which I have taken already. If you can see what I need to do, we need to first do the installation, the MQTT installation. So you need to just pip install Paho MQTT. If pip is already installed your computer, that will be great. If it is not installed, you need to execute some command to install the pip. Then you need to install the broker. Okay, so you need to install the broker, and after the installing the broker, you can execute your Python program. First, the publisher program, you can see here Python publisher.py, and then you can execute your subscriber program. Okay, on another terminal. So you can see here, once the publishers execute, they will start capturing the temperature and start publishing the temperature after some delay. Obviously considering some delay and all, not delay, sleeping period, and then the same details you will get on the here's at those who have subscribed the topic, they will get the details. Yes, this is all about the MQTT protocol, which is using the publish subscriber model. Yes, now if you have any question, you can ask me. I'm done from my side, this MQTT protocol and all. You can definitely try it your own. It's really interesting protocol, because here we are trying to collect some data. We are publishing, subscriber are subscribing a topic. Yeah, it's really helpful if you are looking for any real-time application. There also you can use this publish subscriber. Even though if you want to give a visual like any like analytics kind of things, that also possible. Or you want to use for example, just now we have used a ThingsPick account to just showcase our data. That is again a possible. Yes, so this is all about from my side. If you have any doubt, you can ask me.
I request participants, they can ask their questions or they can share feedback for the session.
Yes, if you have any doubt regarding the ThingsPick or the any like Tinkercad or the MQTT protocol and all, you can ask me anything. Even though we can also do one thing, we can control. For example, I have also tried that if I have with the help of mobile phone, you can just turn on and off the things which are available on a Tinkercad. Because nowadays, as a teacher, I can understand many students they are facing a difficulty. They are not able to understand what actually we have to do. So for that, you can do one thing. You can make a Android application, and through the application itself, you can just control the sensors and the actuator which are available on a Tinkercad. So that is again a possible. That also you can do it. Same like just now I have shared with the Tinkercad and ThingsPick simulation. So that also you can do it with the help of Android application.
Ma'am, I have a question.
Yes, ma'am.
In Tinkercad, how do we know how to make connections? Because what I have gone through is some tutorials and tried to make some connections using those tutorials. So is there any thumb rule, or because I am a computer scientist, so I don't know about connections. So how we can go along with the connections?
Okay, so for example, initially you mean that circuit design or the coding?
The circuit design, the wiring.
Okay, the wiring and all. Just a second, I'll share my screen with you all. So what you need to do simply, basically, if you at least you need some basic electronics understanding, because if you are going for any sensor or the actuator, there are some pins, like if you are looking for the like LED kind of an so I have many designs with me, I can show you. If you are a beginner, if you want to start, you just need to click on the circuit, then you need to create a new circuit. Okay, can you see my screen? Is it visible?
Yes, ma'am.
Yes.
So here you need to create a new circuit. So once you create a new circuit, it takes some time. So here, this is the blank panel. So what you need to do here, on the right hand side, you will get a lot of options. All the sensors, actuators, and the different boards are available. Whereas right now we are discussing about the Arduino Uno. So you just need to drag and drop over here, and with the help of trial and error we can definitely do it. So if you are a beginner, don't worry, they will give you all the help. Means if you, for example, there is no need to write a code. If you can see here, I want to turn on the and off the LED. I only drag and drop the LED, and I know that this LED is having two legs, one anode and another is the cathode one. Okay, so as per the basics electronics, we need to understand ki cathode we need to connect where and anode need to connect where. So for example, even though if you are having any wrong connection, so for example, if I'm connecting to the here, and sorry, just a second. So here I'm connecting to pin number 6. Okay, so this is the connection which I form. I don't know where to connect the ground and where to connect the VCC. If the connection is the correct, they immediately start the simulation. They will not give you any error. Your LED starts blinking. But if there is an error, you can see here my LED will not turn on. Even though on a Tinkercad it's really great, you can code the particular LED in a block coding or in a text coding as well. I would like to suggest you can go for text coding. So you can select over here block code or the text code. I would like to go with the text code. So I have click over here text. So once you form the connection, immediately the code is going to be ready over here. Okay. And what we are trying to do here, so they will show you the sample code, which you can see here. This is the setup method. Basically, whenever you drag and drop any device, there is a setup method, which will actually set up a mode. So same like a Raspberry Pi, here also we need to set up a mode. So we are using a LED button and LED, which is the output actuator. That's why we need to write here output, and we have a one loop. Okay, and digital write will show you some action. So that time we used to go with this method, digital write. What we want to show, we want to turn on and off the LED. Means what, we need to give a high voltage and the low voltage. Whenever we are giving a high voltage, for 1,000 millisecond will turn on, and again we are lowering. If you can see here, we have load after 1,000 millisecond. What we have mentioned, low. That's it. So this is a really simple code. There is no need to write a code here in a Tinkercad. So it means that once I'm going to be click on the simulation, my LED is not blinking. It means that there is some error. So you can just do one thing: stop the connection, remove it. Okay. So here, what you need to do, even though if you want to change the color of this jumper wire, you can change it from here. Okay, so I've changed it in a black because I've connected to the ground. Then I want to go for the VCC or the input output pin, because I want to control this LED. I've connected to pin number 3. Okay, or for example, if you don't want to connect, you can connect to the pin number 3. Oh my gosh, yes, pin number 13, for example. Wherever you want to connect, any GPIO pins, any pins, input output pins, you can connect. Again, I'll start the simulation. Okay, so once you start the simulation, you can see the effect over here. Okay, even though, for example, here, which kind of a voltage they are giving you. Apart from that, many people, they avoid to use the resistors as well. So that resistor also you can add. Register, so register means most of the time to harm the LED, to not to harm the LED, we can use the register as well. So unless and until you are not going to be do the exercise, you will not get the idea that how to connect, which connections are required. So for circuit design, you can refer the online circuits with the help of that. But I would like to suggest go with the trial and error. Otherwise, will not get the actual idea.
Okay, ma'am. Thank you.
Yes. Anything else?
Thank you, ma'am. Any more participants have any kind of queries in us?
Thank you, ma'am. This is Dr. Prashant.
Hello, sir.
Ma'am, session was very, very good and very exciting for me.
Thank you
I
so
have
much.
learned very much practical things first time on this software exposure. So Thanks a lot for that, ma'am.
Yeah,
You have
thank you so much.
explained it very nicely, and its dissemination percentage is maximum.
Yes, thank you, sir.
Thank you, ma'am. Thanks a lot. Thanks for wonderful session.
Yes, sir. Thank you, all the participants, and thank you, all the coordinators for helping me since from many days.
Thank you, ma'am. And I thanks all participants for patiently listening. And I thank you, ma'am, on behalf of Government Polytechnic Daman. The next session will be at 2:30 p.m. At the start of the session, I already told what will be the scenario for the last session. So